Tesla began experimenting with what would later be called X-rays. He invented the radio before Marconi. He began building massive coils that generated electrical discharges like artificial lightning. These so-called Tesla coils frightened the public, with spidery arms of purple lightning reaching out with the promise of energy as well as the threat of electrocution. He dreamt of finding a way to power the world without wires, to deliver electricity through the earth, through the air itself. In New York City and around the world, Tesla was still asked to give lectures on his work from time to time, but he insisted that he be allowed to put on a show instead, to demonstrate his inventions, complete with music and fanfare and all of the trappings of showmanship. The audience members expecting a dry lecture on the nature of energy would often find themselves in the middle of a production number, soon to discover that bolts of lightning would be produced before them on stage as well. Tesla invented radio-controlled boats, robots, the spark plug, new fluorescent lights, and countless other devices. And in 1899, he moved off to the seclusion of the Rocky Mountains. There, in the high altitudes of Colorado, he lived alone and began building secret devices capable of generating millions of volts of electricity and massive lightning bolts more than 100 feet long. His mental illness kept him from being able to touch other human beings, but he claimed that in the mountains he was listening to radio transmissions from space, precise mathematical clicking of alien messages, his only company. Tesla, the creep, the weirdo, drew away from society, and his reputation as a mad scientist grew.
In many ways, the history of Western thought has been the history for the search for that which does not change. It's unfair to say that the Greeks were obsessed with change, identity, and the eternal, but they're not. We have our own version of Achilles and the tortoise and Theseus' ship. And if we trace the history of the concept of energy, we find that it is indeed an historical notion, a notion that changes across time. Aristotelian physics finds an early root of the idea of energy in its discussion of motion. Aristotle writes, "Was there ever a becoming of motion before which it had no being? And is it perishing again so as to leave nothing in motion? Or are we to say that it never had any becoming and is not perishing, but always was and always will be? Is it, in fact, an immortal, never-failing property of things that is a sort of life, as it were, to all naturally constituted things?" Aristotle's conclusion is that motion has always been and always will be, an empirically eternal constant in a world of change. In attempting to use math and geometry to explain the functioning of the world, Archimedes and other early proto-scientists struggled to apply abstract universals such as triangles and numbers to concrete experience. Such thinkers had already realized that tools and machines could provide an apparent increase in energetic output, but this increase always came at a price. Consider lifting a heavy rock with a lever. A single person can accomplish this difficult task if the lever is long enough. But while it is amazing that an individual can supply the power necessary to lift such a weight a few inches off the ground, it has always been readily apparent that the cost of this was moving the long arm of the lever a much greater distance through space than the rock gets raised. The longer the lever, the greater the force, but also the greater the amount of work one had to put into the system in order to use it. Something hidden was remaining constant. Later, it would be discovered that the thing that remained constant could be expressed by a relationship between the amount of force being put in multiplied by the distance the lever moved, a product typically called the work being done by the force, compared with the weight of the rock multiplied by the distance it moves. This equation balances out. Something remains constant. It was not until the scientific revolution that the notion of energy came to replace that of power and motion. Energy seemed to be a good candidate for what's always stable in the world, even when everything else seems to be changing. If you throw a ball up in the air, it eventually slows down at the top of its arc and falls back into your hand, picking up speed even as it falls. The final speed with which it hits your hand is the same as the initial upward speed at which you threw the ball. Why? Although the ball is undergoing many changes throughout its flight, the entire event can be described in a way that shows there's something constant underlying it. If we define kinetic energy as the energy of motion, and come up with its value by taking 1/2 of the product of the mass of the ball and the square of its velocity, we find that the kinetic energy starts off large, diminishes to 0 when the ball comes to stop at the top of its arc, and ends up the same large amount at the end of the trip. Kinetic energy does not stay the same. Further, if we define potential energy as the product of the mass of the ball, a constant given by the acceleration of gravity, and the height of the ball above your hand, we find that the potential energy of the system starts off at 0, reaches a high number in the middle of the ball's arc, and then returns to 0 when the ball is resting in your hand again. It does not stay the same. But what does stay the same is the sum of the total kinetic and potential energy at any given moment. Stop the ball in any point in its flight, add up the current potential energy based on its height, and kinetic energy based on its speed, and you get the same number. Always. No matter what. And thus, though the ball is moving and the world is changing and things are coming and going out of being, something remains the same. The amount of energy in the system. And yet, what is energy? What is it really? It's not a thing. It has no mass. It's not a force or even an amount of work, but rather a measure of the ability to do work. It's a potential, a possibility, a necessary precondition for the appearance of that which is energetic, but